Hello everyone, my name is Metha and today I'll be talking about space radiation, its causes, its impacts, and some solutions to it. Have you ever wondered why astronauts need protection when traveling to space? Well, there are various reasons for this, such as incoming debris in space, but the specific reason I'll be talking about today is space radiation. But what is space radiation anyways? Space radiation is the radiation that occurs when an atom is stripped of its electrons as it travels at the speed of light. Now there are two figures that can be seen on the slide, one which is a normal atom and the other one is a bit unusual. The first atom has electrons while the other doesn't. The second atom is more likely to release more radiation in space as it only has protons and neutrons and there are no electrons to cancel out the charge of the protons. This leads to more radiation being released. Moving on to the causes of space radiation, there are two specific causes that I'll be looking at today. The first one being galactic cosmic rays, also known as GCRs, and the other being solar particle events, also known as SPEs. Galactic cosmic rays sources are unknown since they come from all directions at a uniform speed throughout space. Therefore, their sources are assumed from the isotopic abundances of these atomic rays. Elements from all over the periodic table have been discovered as a source of GCRs. Multiple experts have also discovered that GCRs are made up of high-energy nuclei. This means that any object in space that happens to collide or run into GCR particles will be affected by the GCR. The second cause, also known as SPEs, can be defined as a bunch of energetic particles that come from solar flares. According to Xiao and Hu, large SPEs deposit large radiation doses for both the crew and the equipment. This means that there is a considerable amount of radiation coming from SPEs. The extreme radiation will affect the crew working on space missions greatly. I'll now talk about the physiological impacts of space radiation. The first impact is an increased cancer risk. Reitz and Helwig state that exposure to space radiation affects cell growth, which can lead to cancer. As we know, cells regenerate every day, and it is a natural process that happens frequently. However, cells that are affected by radiation can create radiation-damaged tissues, which will lead to cancerous tumors. The second impact is acute radiation syndrome, and scientists state that space radiation can increase the risk of said radiation syndrome. The process in which this happens is similar to the effect of radiation on cancer risk, as the damaged radiated cells can lead to cancer but can also lead to an increased risk of acute radiation syndrome. The third impact of space radiation is radiation-induced bone loss. According to Seedhouse, between 1 and 1.2% of bone mineral density is routinely lost each month as astronauts stay longer in space. Mainly what happens is the body goes through a cell cycle arrest where the bone cells are injured, which therefore hinders bone growth. The evidence by Seedhouse shows that astronauts' bone growth is greatly affected by space radiation, and they consistently lose vital materials that contribute to their bone generation. Finally, the last impact I'll be talking about is modifications that will be caused to the central nervous system by space radiation. Multiple researchers claim that possible CNS concerns during a mission include modified cognitive functions. This means that vital processes of the body will be paused in response to the damaging radiation. Things such as receiving, analyze, reacting to sensory inputs, which are things we need to do in our daily life, will be affected. This can cause astronauts' performance to decrease in space. Next, I'll be talking about solutions to space radiation that will help decrease the effects of space radiation on the human body. And while there have been many discoveries in the space industry on things that can help reduce space radiation, many of them are brittle and less practical. The first solution I'll be talking about is polyethylene. Polyethylene is a material that is generally used in making plastic packaging and manufacturing plastic bags and houseware. Polyethylene is a hydrocarbon that is made of multiple molecules of ethylene, which is C2H4. According to Blakowicz and Ehrman, which are scientists specializing in physics and engineering, they state that materials produced from lightweight atoms such as hydrogen and carbon are beneficial against space radiation. In this case, polyethylene is ideal because it is a hydrocarbon. And considering its size, it will be stable to use while shielding spacecraft. My next solution is a material called Kevlar. Kevlar is a material more scientifically known as polyparaphenylene terephthalamide. It is a chemical ingredient used to make synthetic plastic. This chemical is created when an acid is introduced into a solution of hydrogen and nitrogen when beginning a chemical reaction. Kevlar is used to make body armor, bulletproof vests, automobile brakes, boats, and spacecraft. In a source from the European Space Agency, it is stated that Kevlar is used as a radiation shielding material, specifically in space. Kevlar is a good option for shielding astronauts from the damaging effects of space radiation, as it has the capacity to reduce radiation and is durable and is flexible since it is used in bulletproof vests. In addition to that, Kevlar can be used in spacesuits. Britannica provides a video where the utilization of Kevlar is shown. The video explains how Kevlar is used in nylon suits. This proves how versatile Kevlar is as a material and shows how it can be utilized in many space applications against space radiation and other harmful aspects of space. The final solution I'll be talking about is boron nitride nanotubes, also known as BNNTs. They are made up of boron and nitrogen atoms organized in a tubular formation as shown in the figure. And because of its unique structure, BNNTs can be used in various industries. They are generally used in electronic supplies, but they're also effective for regulating temperatures. And they have the ability to increase the strengths of other materials. According to Ghazizadeh, Estevez, and Kelkar, BNNTs are a superior choice in radiation shielding when compared to carbon nanotubes, also known as CNTs. Carbon nanotubes are similar to BNNTs, but carbon-carbon bonds are the ones replacing boron-nitrogen bonds, and they have been known for a while and have been used in space applications, but it has been seen that BNNTs have a higher success rate in radiation shielding compared to CNTs. In conclusion, the issue of space radiation is quite a serious one. Astronauts can and do face numerous hazards from space radiation. Space radiation can cause many things to astronauts, including acute radiation syndrome, increased cancer risk, effects on the central nervous system, and radiation-induced bone loss. Space radiation is caused by GCRs and SPEs, which are natural phenomena that happen regularly in space. And the solutions I have presented in this presentation include polyethylene, Kevlar, and BNNTs, which are all effective at shielding against space radiation. While BNNTs and polyethylene are more suitable for spacecraft shielding, Kevlar can be used in making spacesuits and is more versatile. And here are my references. Thank you for listening.